So, welcome everyone to the OBS Loves AppImage session. Who knows here in this room? Probably everyone knows what OBS is. Show hands. Okay, at least we can tell you some news there. Who knows in this room what AppImage is? Okay, some, fewer. Okay, excellent. So, I'm Simon. I have been working on AppImage since around, it's a bit more than actually 10 years now, under different names. And I've started to use Linux. I was originally a Mac user, so I was spoiled by everything being very easy. I came to the Linux platform and I thought that this whole application handling thing is a bit complicated. So I started working on this project since that time when it was still called Click. But I'm getting ahead of myself, so let's introduce Adrian.
Yeah, I'm Adrian. I'm with the Open Build service since the beginning, and I started to look into AppImage in a hectic project actually, and came in contact with Simon.
Yeah, so what is the problem? As a developer, I would like to reach all the Linux users out there with minimal effort. Writing the application once and being able to ship it to everyone. Of course, on the flip side, as a user, I would like to be able to go to a website of an application and be able to get this application not only for Windows and for macOS, but also for Linux. If you look at websites today, application websites, what you typically find is a download page where it is no problem to get the Windows version and the Mac version, and then you have a whole page of description what to do if you're using Linux. And this is even true, and that's a sad story for open source applications. I have seen this multiple times where it is easier. A year ago, it was easier to get something like a video editing application, KDN Live, which is a KDE application. It was very easy to get on Windows. One file, you download this file, you install the file, it runs. It was very easy to get this for macOS, same thing with the DMG file. And then for Linux it says, yeah, use your distribution, but it's probably outdated, so use this repository and that APA, and you need some libraries and patch listing, and in the end they say if you really want the newest, install it from scratch, compile it from scratch. And that's really a sad state for Linux application packaging. That is especially true if you're running a stable base system, like an enterprise version or an LTS version, and still would like to have the latest application software. So really with AppImage, I tried to have something that can stand next to an EXE and a DMG. For this question, how to get applications and software in general to users, there are multiple approaches. And today we are talking about OBS and about AppImage. So approach number one, OBS. Adrian.
So we faced the problem also years ago. We had in the old times our distribution, we built it only internally, but we wanted to ship out newer KDE releases. So we had a supplementary repository, and we had some crew tags running on my workstation basically, building RPMs, copying it out, running a trade repo, I believe, at that point of time, not sure what format, but you were able to download the RPMs and upgrade your distribution. So even though it was not part of the distribution, but we used the tools which were used to build the distribution also to build these add-ons. And we opened it at some point of time, especially when the openSUSE project was started. So before it was could only be done by SUSE employees, but with the Open Build service, the idea was that really everybody can go there, package stuff, build it in a transparent way, and make it accessible for everybody to scale our workforce in the end. And the concept is basically you have put some source, and then there are some base binaries which are already provided. It's the base distribution usually, and so OBS is always checking, has the source changed, has the binary changed, and then it retriggers the build and publishes it. And the good thing here is you can have many sources and many binaries, and so you have an end-to-end dependency, so you can build lots of packages for lots of platforms, and you have a nice overview. The project monitor, you know most likely from the build service, you get very fast a feeling where it is breaking. You have an overview where it's broken for openSUSE or it's broken for Debian, and you can fix it there. But you have all parallel builds, which is for one side a good thing because it's really optimized for this distribution. So when factory introduces new checks, because we say it's quite a problem if system D service files in that kind of way are installed, it might introduce security things or might break other services, so we can introduce new checks. And you as a packager can see that right at the build time already that there's a problem and you can fix it. And we can introduce new checks for newer distributions, for example, while still keeping it working for older ones. So we can react also when the distribution is changing. And it's of course always optimized for this particular distribution because the compiler and the libraries from this distribution are used. And it's shipped, you have to get a package which only is the smallest possible shipment basically. So it solves a lot of problems by building it in parallel.
So really, a big part of the problem is solved by this OBS thing, because now an application author doesn't have to wait until Debian puts the application into the distribution, but you can really use OBS to build packages essentially for most of the common distributions. So that's already much better than the situation was before. But still, some of my problems were still not solved. For example, as an application author, I still cannot link to a single file for Linux. I still have to link for every different distribution to a different package. Also, if I want to package my application, I still need to understand how the native packaging system of each distribution works. For example, if I want to reach openSUSE, I need to know how to write an RPM spec file. And if I, at the same time, want to reach Ubuntu users, I have to understand how Debian packaging works as well. Not only how the tools work, but also how the policies work, because if you don't follow the policies, then it's not a proper package. So still, with OBS, that's a great tool set, but still a lot of work for the person who wants to distribute an application. The user also is still following the same model as distributions install things into the system, which means you have to be root. You need root rights first of all, so I can't just take this application and run it on a university lab PC where I don't have root rights. I simply cannot add software to that. I still need a package manager, which means if I install the latest leading edge of something on my enterprise stable distribution, then I'm not guaranteed that this enterprise stable thing is really still enterprise stable because the libraries have been changed and messed with. So really, there is still not this, I have my base system which is untouched and can just add one file on top of it. Meanwhile, in AppImage land, this is the second approach to this issue. I took a totally different approach, whereas what Adrian described really followed pretty much the line of thought of a distribution. I really came in with a non-distro approach, like I call it, and essentially tried to replicate what Windows and macOS have been doing, one could say quite successfully, on the desktops, given their market share. So the undistro approach is really to have one file like exe and like dmg, which is AppImage. Now, what is an AppImage? The central idea behind this is to really split the stack into a base system, the operating system, which comes from and is managed by the distribution, and which I, as a user, don't want to even touch. I trust the distribution to manage the core system, the kernel, the boot system, the libraries. That is the scope of the distribution. I tend to use a distribution like I would use Windows or macOS as the base platform. on top of which I want to run applications that are not coming from the distribution, but really are coming directly from upstream from the application author. I will now show how this works in practice. Actually, this morning, someone posted on Twitter that they just had released a new software for Linux. And they did so in an AppImage format. I just went to their webpage, downloaded this one file, and it's 40 megabytes in size. What I have to do is to go to Properties, Permissions, set the executable bit here, because I just downloaded this file off the net, and by default the executable bit is not set, which is a security feature in Linux, so I allow executing this file as a program, and then I just double click it, and if we are lucky it should run. There it is. Actually, I don't know what the software does, I just literally discovered it while sitting outside this morning. And this is why I like this. Every day I can discover new software that someone just put on the net, and at the same day it's released, I can run it, no matter what distribution I'm running. So how does this work? The idea is a very simple idea, and that is every application is one file. So you can have as many app images as you want. It's always one file per application and per version of the application. And this includes two things inside of the file. One is a tiny executable at the header of the file, and then a large file system image, squashfs in this case. It used to be ISO, now it is squashfs, but really it could be just about any file system. What the executable does when you launch it is it takes the file system image and mounts it with fuse, and then executes whatever is inside the squashfs image. So inside the squashfs file image you bundle the application and everything that the application needs to run, except the things that you can reasonably expect to be there already in each of the target systems that you're targeting. So for example, if you want to target openSUSE and Ubuntu users in a certain version, let's say you want to target all distributions that came out in the last 3 years, you would have to bundle inside this file every library or dependency that is not part of those distributions that you're targeting. And that is your choice as an AppImage author, what to bundle or what not to bundle. So let me point this out. We don't just take the approach of let's bundle everything. Very basic stuff like glibc, or one could discuss about GTK, for example. These things that are really core to the operating system should, in my opinion, not be bundled with each application, because that should really be a common infrastructure that every Linux distribution should agree on, and it should just be there for other people to take advantage of. This also means that when you put together an app image, it is recommended that you build your binaries on an old build system, not on the latest bleeding edge stuff, because if you take the latest bleeding edge build system, you will have dependencies on the latest bleeding edge versions of all the libraries, including the basic ones. If you don't do that and build on an older system, it is more likely or almost guaranteed that it will run on less than bleeding edge target systems as well. So really, that's all it is. An app image is a file system image that mounts itself when you execute it and runs what you have put inside that image. That's it. Except for a few extras. One is, now that we have an application in just one file, we can do new stuff that wouldn't be so easily possible otherwise. For example, we can apply binary delta updates. Imagine a big game, a couple of gigabytes large, doing nightly builds for testing. If the game does this as an app image, they can do what we call binary delta updates, where users just download the few bytes that have changed between yesterday's build and today's build. And for a 2 gigabyte app image game, it could be that this is just a megabyte or 2 megabytes, because only the blocks that have changed in that file system will be downloaded. Also, there is sandboxing. Sandboxing is implemented by independent third-party projects. One example is Firejail. They have native support for AppImage, but I have tested to run AppImages, for example, also in the bubble wrap sandbox that Flatpak uses. And I'm sure if you prefer to use a different sandbox, again, that would be possible. Technically speaking, the sandboxing is not really in the scope of the AppImage project, but something that is complementary to it. Finally, there is an optional part called appimaged. This is a little daemon that runs all the time in the background and integrates any app image that you download into the menus, installs MIME types, icons, and so forth. But it's purely optional. Actually, on this machine that I'm running here, I don't even have it installed, just to make the point that to use an app image, all you do is download one file, set the executable bit, and run it. Everything else is purely optional. So this solves a lot of problems. It works for all the common Linux distributions. It lets users to run the latest applications even on mature LTS enterprise distributions. It is really simple with just one file to download. You don't have to mess around anymore with repositories, PPAs, and so on. Just download this file, make it executable, and run. Also, it is very fast because there is no unpacking or installing involved. Think again of that 2 GB game. You download it, set the executable bit, you can launch it. You don't have to unpack it before. So this really solves a lot of issues. Also, we don't need root. We are always guaranteed that an app image doesn't mess around with your system because it can't touch your system, or it doesn't need to touch your system. Also, it can't because it has no root rights. It works out of the box. You don't need to install something before you can run an app image, so there is no runtimes. And this means it also works on live systems, live ISOs, university lab computers, and so on. And what's the cool thing is, it's also great for dual or multi-booting. On my system, I have a couple of different operating systems, all of the different distributions, but only one set of applications, because the applications are all in app images, so no matter what operating system I boot into this day, I still can use all my applications. So really, it solves a lot of things, but as always, it doesn't solve everything.
The mean part is that it moves around the problems to the user.
And by the way, Linus at some point thought this is very cool. And when that started, then adoption also started with projects like Kdevelop, Pretam, MuseCore, OpenShot, and a couple of others. Also companies got interested. JetBrains did their JetBrains toolbox, and at some point even Microsoft did a PowerShell app image.
Disadvantage, of course, in putting everything in an image, so copying basically all libraries and so on. And the standard argument against AppImage or Docker or whatever container you build is that then it's up to the user to check if there are the other parts of the image or outside of the application are still the secure things. So for example, you have a file manager which provides some export functionality, so it packages Samba. Then since you maybe read yesterday or 2 days ago, everybody can take over this container. So everybody is on your system. And how should you know? I mean, there's so many components inside, it's not possible for a single person and just to track it. So you need basically the help from distribution people to get the updates, to rebuild the app image and push it out to users again. So yeah, that's what I said. So it's nothing is really checked again. It's just a point of time. The guy who wrote the application and packaged it was happy with it. That's all what you know. He was happy with it. You have no clue what the current state is after 1 year, or it's still a file hanging around somewhere. You have no clue how he built it, what he put inside, where the stuff comes from.
So this guy who has put Samba inside his app image now really has the burden of updating this and tracking all the security issues and legal issues and so forth. And this is where a distribution has actually solved all these issues, but now it would be cool if the person putting together the app image could make use of that.
And here did we meet, I wanted to say. That was the argument from Richard Brown.
OpenSUSE chairman made that point that distributions have decades of experience in exactly this kind of problem. And all these new packaging formats should not just reinvent the wheel or have this unsolved, but really use the experience from the distributions that is already there.
Right. And so we did.
So really, OBS and AppImage even better together.
Because we can have both of those worlds. OBS is doing all the tracking for RPMs. We do it already for key image. And now since we can also build app images, we can build reproducible. So in the ideal case, you have a very small YAML file where you see, okay, it's using these sources from this Git repo, and it uses these RPM packages from these other projects. So if you trust these upstream projects, it's very easy for everybody to use if he can trust about the app image.
And as a person putting together the app image, this is great, because I now, as an application author, just have to worry about my own source code and all the dependencies OBS is managing for me, and outfalls, constantly updated app images. For example, if that Samba changes, I don't have to do anything anymore. The app image is automatically updated for me with the latest Samba.
Right, and it pops up at the user screen, or the daemon is updating it automatically, so even the user doesn't need to care. So it's fully automated. It can be set up also with Git pushes, that a Git push to the server also triggers the rebuild. So if nothing is breaking, can happen of course that a change is breaking something, then you will get mails that something has failed. But until this happens, it's fully automated, and you will see. Nobody has to touch anything.
So we have about 5 minutes to go. Perhaps we can give a very small demonstration of a hello world kind of application.
So, yeah, Home Pro Bono is Siemens Home project. And you should see we have a number of examples there.
Let's take a Qt Quick app, for example.
Okay,
so this is a tiny app, just a hello world app written in Qt Creator with Qt Quick. And this lives on GitHub. I just put the source code on GitHub. And now Adrian will show how to take that GitHub sourse code and make an app image of it.
I will just show you how it's set up. So all what the user has provided here are 2 files basically. For one, it's a AppImage YAML, which is a build description. So what you see is this is an example which is not using RPMs, but is using sources. So what it does is it mentions that, okay, it takes the source from this URL and then build it. So these are the standard steps for just building compiling the application, and the Linux deploy Qt application will prepare the app tier, the directory, which will be then later on packaged into the image.
Essentially what it does is it takes a subset of Qt or a subset of other libraries that are required and bundles those libraries into the application directory, so that you don't have to do all of that manually, even though you could. You could copy in every library manually and do all of that work, but this is what Linux Deploy Qt does for you. And Linux Deploy Qt works for Qt applications, but also for other applications.
Yeah. So don't be misleaded by the Qt part of the name. It's not limited to Qt. So this is the one part, and then macOS.
That's not macOS, by the way. That's openSUSE.
That's GNOME. That's the problem. No.
Is it not? Do we have network?
No network. And the other thing is just that the service file. No. It's this single service file And this is super simple. It's just mentioning the AppImage service. And what the AppImage service is doing is parsing the YAML file. It will see the Git URL, and it's basically downloading the source. So all these service column files are the result of it. So it's really two very simple files in the end, which you need to provide. And meanwhile, we have also a template for it.
Okay, looks like we have a network connectivity issue, but time is up anyway. What we should point out is here on the right-hand side, you see all these nice builds here for all the architectures. This is really cool. So by just providing, this is the service file by the way, by just providing a couple of lines of definition, OBS takes this and builds app images for all these architectures. Let me show you real quick how the final product now looks like. I've already downloaded it beforehand. Here it is, again, single file. This is a full Qt application. Again, here I'm running openSUSE, no Qt on the system at all. So a subset of Qt is bundled inside that app image. It's 13.2 megabytes in size, so I would say not too terrible. I just go here to properties, properties, permissions, check this here, and then double click it. And this is the little Hello World Qt application. So what we just did is, we took an application out of GitHub, had OBS compile it for 4 different architectures, including ARM, put it into an app image, into a single file that a user can download, make executable, and run on a stock system where not even Qt is present.
And in this example, we built it by source, but also the other way is possible that you just reuse an RPM, for example, which you built before, and convert it to an image. So it's more or less the same. We have a template out there now, which is commented, and you can see how this is going to work. So it's, for example, I use it for the FreeCut application I maintain. This thing is compiling 40 minutes or so. And it's very valuable that you don't need to recompile it every time just to figure out how to package it for AppImage. So I can just reuse already built RPM and fix and tune my AppImage packaging. So both ways have some reason. This example, when you build it, you don't need to know anything about RPM, about macros, about policies. This is just as you are used to build it on your workstation basically, but the other way is also working.
So I'm sure you have lots of questions. Unfortunately, the time in this talk is almost up now, but if you have some time, probably some of you have even signed up for the packaging workshop, which will actually start in 2 minutes in room 2, in the room next door here. So we can use the first couple of minutes there to do more Q&A than it's possible right now. But before you leave, I would like you to check this out, appimaged.org, and also the IRC channel AppImage on Freenode. This is where we all hang around, and if you have any questions that you can't ask today, feel free to join there, and there's almost always someone who can answer questions. So with this, we now have exactly 1 minute left. Maybe we can do 1 or 2 questions at least. Yes? Oh yeah, how many projects are using AppImage? So there is on our wiki a list of projects. And here I'm just tracking official upstream app images, so not counting things that just a random guy made. These are all really legitimate upstream things, and you can see the list is really growing.
Links.
This is links to the original projects, and sometimes you even have big names there, like IBM, and there is one from Microsoft and so on. So check this out, it's on the AppImage kit wiki. It's also linked on the main appimaged.org page. More questions?
2 quick.
Okay.
Fuse. Only Fuse, or are there other file system options?
You can, on systems where no Fuse is available, you can extract an app image. And this is actually built into the AppImage thing. So if you run the app image with --appimage--extract, it will just unpack itself.
My second question is too long. I'll ask it in the next one.
All right, so unfortunately time is up, but everyone is invited for the next room, room 2, where now the AppImage packaging workshop will start, and we can do more.